Hello guys, once again welcome to my compiler series. In this video, we are going to discuss a very important topic that is input buffering. It is basically a technique used by lexical analyzer to read the source program efficiently. Okay, instead of reading one character at a time from the file, the lexical analyzer reads a block of character at once. Uh, we can ask that why don't we simply read one character at a time? Uh, because reading one character at a time from memory or disk is very slow and expensive also. Okay, every character reads causes an input output operation, and input output operation are the slowest operation in a computer system. So this is why buffering is needed. More input output operations means slower compilation. So how buffering helps here? uh, we can say that buffering reduces the number of input output operations by reading multiple characters in a single operation. Okay, once characters are inside the buffer, the lexical analyzer can access them very fast. Okay, so let's discuss the two buffer scheme, which is very important. It's always asked in the examination. Okay, to further improve performance, lexical analyzer uses a technique called two buffer schemes. In the two buffer scheme, the input is divided between two buffers, buffer 1 and buffer 2. As we have seen here, Mm, we have one sentinel character which marks the buffer end. We can see that this is the sentinel character, which says that this sentinel character says that buffer 1 is exhausted and now you can fill buffer 2. Okay, each buffer ends with a special character called special character sentinel. Okay, so its main purpose is to mark the end of the buffer and tells the lexical analyzer that buffer is finished. While the lexical analyzer is processing characters from buffer 1, buffer 2 is filled with the next block of input. When buffer 1 becomes empty and the sentinel is reached, the analyzer automatically switches to buffer 2. At the same time, buffer 1 can be refilled with the new input. This is the main working of the two buffers. Okay, we can think of it like two plates. While you are eating from one plate, the other plate is being refilled. Okay, so why two buffers are better than one? Using two buffers avoid frequent access and prevents the lexical analyzer from stopping. Because if we use one buffer, then if the buffer is filled, then we need to wait for some other arrangements or some other buffer. So to prevent this, two buffer techniques ensures smooth and continuous scanning of input. Okay, because of the input buffering, the lexical analyzer becomes much faster and more efficient. This significantly improves the overall performance of the compiler. Hence, we can say that input buffering is used in the lexical analysis to reduce input output operations and improve efficiency using a two buffer scheme with sentinel character. I hope I am clear. Okay, so next let's discuss what are the specification of tokens. Tokens are specified using patterns and regular expressions. Okay, so let's first see what are the components of the tokens. We have token name, lexeme, attribute value. Token name is like ID, num. It is a symbolic name representing a category or class of lexemes. Okay, then lexemes are the actual string, which is the extract text written by the programmer. Then attribute value are the symbol table pointers which provides additional information about a token, especially when many lexemes share the same token name. Okay, so let's discuss what is a pattern. We will discuss this in the unit 2 also, but let's discuss. Pattern is a rule that describes the set of lexemes that can form a token. Okay, the patterns tell the lexical analyzer how to recognize a token. For example, we can say that if we have sum equal to total plus 10. Okay, so what are the tokens in from this and what are the lexemes? So as we have discussed above, lexemes are the actual string values. Actual string values are like sum, total, 10, and tokens are the symbolic name that represents the category or class of the lexeme. For example, sum is a ID, okay, then total is a ID, okay, 10 is a num plus an assign value, okay. So these are the lexemes. So now let's discuss the very important question and always or asked in every college examination, that how to count number of tokens from a given code. They will give you a code and ask you to count the number of tokens. Okay. So the key rule is, while counting the tokens, write this in your mind first. Uh, a token is a category, not the actual value. Okay. Each keyword, identifier, operator, constant, and delimiter counts as one token. For example, we have if we have this program, okay, so here we have while x is not equal to 0, x equal to x minus 1. We can say that here is a space, but space is not counted as a token, okay. Not white spaces, and also comments are also not counted as a token. So let's count. First is while 1, then 2, then 2 is that opening bracket, 2, 3, then this will consider as a one token. As this is one operation, this is a relational operation, right? This is considered as one token. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the answer is 14. We have total of 14 tokens there. We can exclude comments from the token list, and also white spaces are not counted as any tokens, and this relational operator is counted as one token. If we have any assignment value, for example x equal to 0, then this line contains three tokens. One, this is 1, 2, 3. But if it has equal to 0, then also it has three tokens. I hope I am clear. It also has three tokens. Okay. Okay. That's the end of unit 1. I hope I am able to clear all the concepts of unit 1, and let's see unit 2 from the next video. Okay. Bye.